bad poetry time. Have a terrible poem? Yes. What is it? Can I read it out? Okay. Roma brings me pain. The dice I want to destroy. Why does Forum win? That's fantastic. There once was a genie called Roma. Its effect was quite like Soma. The battle die made my opponent cry, and then he went into a coma. That's not bad. That's not bad. I want something worse. Does someone have something about love? Or about being different or something like that? You do?
I have one about love.
Can I read it?
It's pretty bad.
That's pretty bad. It's good. My heart is torn in two. She took one half and ran away. Where will I find my baby to make me whole again? Oh, that's fantastic! I like that. That's an awesome one. You got like two, you ticked 2 boxes. Does anyone have anything that's worse than that? I'd like, oh yes. Yeah.
Roses are red, violets are blue. This poem is speaking so you. The roses are dying. Violets are rotting, the roses are dying. This poem is stupid and so is you.
Oh no, that's good because that's got the whole journey, the whole cycle, the arc of love and then disappointment and then anger. Cool. But I really want one where every second line rhymes. Like, I really love you very much. I love it when we hold hands and touch. My love for you is very bad. When you're away, it makes me sad. But now you've come back to the lecture, I'm happy. And my baby, I love to change its nappy. Yes?
Dodgy. If I were a lettuce and I was split in two, my leaves I would give away and my love is all for you.
That's fantastic! Oh, if I was a lettuce and I was split in two, my leaves I'd give away, but my love is all for you. Oh, that is... Because that sounds deep, doesn't it? Okay, this is fantastic. Woohoo! Okay. How close? Are you ready to go? Mario is setting something fantastic up. This is Mario who posted on the forum the awesome idea about how to do pair programming remotely. Can I just talk a little bit about pair programming? Because that's a topical thing at the moment. As you know, in the course, we've got a budget for how you should spend your time, and the total amount of course time we've budgeted is 150 hours. Now, if you're stressed because the course is making you work too hard, but it's only working you 150 hours, but you think 150 hours is too hard, I can't do anything about that because the course really is supposed to take 150 hours. If you're stressed because you're working too hard and you're working more than 150 hours, then that's a good reason to be stressed, and please work less. And we've given a budget for how much time we think you should spend each week. Just spend that amount of time, if you want a credit, just spend that amount of time, unless there's something you haven't got that you really have to get, because that's like study, you have to work things out, you can't get them. But in terms of just hack time, just spend that amount of time and plan your design so that you deliver the best features you can with that amount of time. So you might not be able to do the whole thing. In the amount of time I set myself to write the reverser, I wasn't able to do the command line things very well. But I figured the most important thing was reversing, so that's all I did. Okay, just do what you can in the amount of time. That's your objective. Don't try and make a perfect thing, because the sky's the limit. You'll never make a perfect thing. Some people are worried because they're spending too little time, because everything's with partners and their partner might not be so interested and might not be wanting to work so hard, and that's frustrating. Now, if it's your design partner, that's okay, because you'll cycle through 3 of them and you'll probably get one that drives you nuts and one that's fantastic and one that's in the middle. So just think, oh, well, good, I've got the one driving me nuts at the beginning now, it's out of the way. So that's sort of okay, because you're only with them for 4 weeks at a time. But if it's your project partner that's driving you nuts, that's not very good, because you're with them for the whole course. Now, we did bust a gut to try and make sure everyone got matched with people of equal motivation and likelihood to get equal marks. We looked at your pass marks and we looked at your performance. When we gave you a task to do for the tute, we looked at how much effort you put into it and if you gave a damn and things like that. And we tried to match like up with like, and we might have got it a bit wrong. So I'm sorry if we didn't get it perfect. Well, we won't have got it perfect, but I am sorry about that. So you might be stuck with a partner that doesn't want to work as hard as you, in which case just do the best you can, and with the spare time you've got, just do the extension work and the brownies and the challenge exercises and things like that, because they'll teach you more than doing extra time on the project ever will. And the last problem is, what if you're happy with 150 hours, you're happy with your partner, you're all prepared to work hard on the project, you understand how hard you have to work, and you know you're not going to work harder than you want to work, but because of your crazy timetable and their crazy timetable, you can never see each other because they only want to come into uni 2 days a week and they've jammed all their time into 2 days, so they've got 3 days for a part-time job, and you've got jammed everything in and keeping Wednesdays free so you can go to the old people's home, and you've done all these extra stuff, and then now you can't do that, and that's really hard. So I don't know the solution to that. I don't know a perfect solution to that. I know some ideas. One is, a lot of people talking about travel time, which confused me for a while because I figured you have to do that anyway coming to uni, but I think maybe some people are coming in on days they don't have anything else on, and they've managed to get a clear day and they have to come in, and then that's really annoying. And maybe their partner's just saying, come in for an hour, and they have to do like 5 hours travel time to do an hour's work with your partner. And I think that's a matter of sitting down and having a good hard talk with your partner, saying, look, it takes me 4 hours to get here and back. I can't just have a 1 hour meeting, and work out it. Be honest with each other and talk about it and work out a sensible plan that works for both of you. Maybe in that case, do it on a day you're already in here, or if you're traveling in specially for it, then do like, you know, a big thing. If you really just can't make it work, you try as hard as you can and you can't make it work, then use Mario gave a link to some excellent stuff you can plug into Eclipse that'll let you work remotely, and it works quite well, but slowly if you're doing lots of stuff.
Sort of haven't tested it yet, but
It looks. Has anyone tested it? Someone test it and tell us how well it goes, but it looks like it's going fine, except a bit slowly if you do lots of things simultaneously. What is it? The link's on the front. I can't remember what it's called. I checked it out in SourceForge or wherever it was.
yeah, I'll put it up on Wikipedia if you guys like.
Yeah, it's just in the forum if you search for it. But it lets you remotely work, and then you just open Skype, you chat to each other, and you're coding, and you can see what's sort of happening. It's not the same as pair programming, but you know, if you had to do that, I guess you could. So just do the best you can. Just try and make it work somehow. Worst comes to worst, and you might have to shed pair programming. But because that's my main hope for this course, is that you'll learn pair programming. I mean, it's up to you how you organise your time and study, but I would strongly suggest you try as hard as you can to take pair programming seriously and try and become a good pair programmer. And the only way you're going to do that is with lots and lots of pair programming, because it's a really useful skill. It's hard to actually teach, but you learn it by doing it. And you'll never have as good an environment to learn it in as now, in a course where we're devoting our time to it. So grab the opportunity and learn pair programming. Now, Mario wants to show something. I'll turn the lights off. This is amazing competition, but I'll let you, I'll swap the screens around. Do you want to just talk about it and what it's like?
Yeah, sure.
You want to take the mic and...
Okay. Is that cool? Can everyone hear me? Yeah? No?
Hang on, I'll turn it up. Go.
Hello. Yeah, so a couple of weeks ago an email went out from Brad Hall, I'm sure most of you have got it, about robocode. I've been chatting to Atlassian, the people that were going to run that competition, and they're a little bit confused why there wasn't so much participation. I think it has something to do with the fact that link didn't work and nobody could get any details of the competition. But anyway, they decided to postpone it, and I thought it would be pretty cool to demo it to you guys really quickly. In about 5 minutes, you can get a semi-decent competitive robot going. And it turns out that this works sort of well with this lecture, because until we did this first hour, I didn't actually realize that I probably couldn't show you any of this stuff. So what we have here is Eclipse set up with robocode. Robocode is simply a Java game where you get a virtual robot that's got a radar, a gun on it, and its body. And everybody's robot is the same, but the implementations of how you control that robot are different. So all your robo code that you write for your robot gets put together into a game, and you all sort of battle it out, which we'll see in a second. So just the Eclipse set up really quickly, new project, new class called AwesomeBot, and the only thing to note here is that we're importing the library. which is the robocode library. So you can just download the game, run it yourself. If you want to start developing with it, you reference the library in a new project, and off we go. So what we're doing here is we've got AwesomeBot extending, mouse not working, AwesomeBot extending and Advanced Robot. So Advanced Robot is a class, Advanced implying is also a robot class. A robot class gives you simple things like you can turn, you can go straight, you can spin your radar. The reason that we're going to use an advanced robot is a robot only has blocking calls, so if you tell it to turn 360 degrees, that function will lock up your robot until it finishes that turn and will go on. So in this quick demo, I'm going to show you guys something a little more useful than that because you sort of get boring robots that only do one thing at a time. Alright, so the first thing that we're going to do, actually wouldn't have to do anything, that's it. You're now eligible to compete in the robocode competition. So, let's boot up robocode. There we go. AwesomeBot. Now, AwesomeBot probably isn't too competitive against anybody else other than the sitting duck. Well, the two of them headed out. Pretty exciting stuff. Hold your breath. Bam! Yeah, it's all amazing music. I actually haven't tried putting in the Java X sample things. I'm not sure whether you can play music from your bot. Maybe like when you win, you know, Eye of the Tiger or something. Yeah, so as you can see, nobody's doing anything. And after a certain amount of rounds at the top, they just start losing health. They're doing nothing. So I'm pretty sure we increase the frame rate here. That doesn't seem to do much. Well, they're just dying. They're dead. So if we just run it out through the whole 10 rounds, they both came first. So we're sort of winning at the moment. Let's go and put something useful in it. So the first thing that we're going to do, as Richard was just saying, we're extending Advanced Robot. So if we take, I don't have it up here. That's all right. There's the Java docs for robocode, like there would be for most Java applications. If we take a look through those, we'll find that Advanced Robot has a run function. So we've got a public void run that we can override. And the first thing that we're going to do, while true, so forever, we are going to turn radar right, radians, double dot. What does it do to infinity? Alright, so perhaps slightly more competitive. The really cool thing about working this with Eclipse rather than Robocode's own built-in editor is that every time you save, you can just tab back. You can actually just stop it, change stuff, come back, restart, and you won't have to recompile or anything.
Change it.
So, whoops. Yeah. A little too quick. Get back to some type frames. Restart. So now, but alright, that's cool. So he's spinning his radar, but he's not really doing anything. So here's where the interesting bit comes in. We will also find, if you look at the Java docs, which we don't have here, that Advanced Robot has a public void unscanned robot, scan robot event E. So, guess what we can take from this is that Robocode will take in a robot, your robot, and every time that your radar scans a bot, it will trigger your own unscanned robot function. So our robot is obviously doing nothing because the one that we inherited probably had nothing in it. So we're overriding it now, and we are going to put in a bullet for 1. 1 being the power, we can use 3, but every time we shoot we lose some energy, so we're not going to use too much energy for now. And just restart that again. So we're getting there. I mean, you could definitely submit this, but not sure how well you do in the competition. Cool. So now we have got a scanning loop, and every time we scan a robot, we shoot the gun. Well, that's a bit silly. what we want in there as well is to turn the gun. We want to turn the gun to where this scan enemy robot is, and then we want to shoot some stuff. So save time. So this event that we had up here, it's got a get bearing in radians, which returns in radians the bearing of that robot relative to our bearing. So what we're going to add to that is get heading radians, which is where we're heading. So that gives us absolute bearing to the enemy. Then we've got this nice little function in utils, which is a robocode thing, that gives us the normal relative angle. And in there we can put the enemy. And so that's taking the gun to where the enemy absolute bearing is, but that would constantly be flying it everywhere, shooting a gun all over the place. So we need to subtract from that where our gun currently is pointing. So we'll get that little difference and move to that. So to do that, we can get gun heading radians. Cool. So this probably needs to be a bubble. And we'll see what our bot does. Yeah, so that's working pretty well. And I think our bot may have just become effective against 2 sitting ducks. No, it's sort of undecided. Well, he'll probably kill one and then lock in the other guy. Anyway, that aside.
And presumably that's because it's before the gun gets a chance to turn around pointing at it, already the radar tells it to go back.
Yeah, so what's happening here is we've got our radar sweeping 360 degrees, and that on-scan event is set every time, but it takes some time for the gun to move. So we've got it sweeping the first one, the gun's like, I'll go there, and it sweeps the second one, and he's like, no, I'll go there. And all the while, you can't, as you can see, it only shoots a bullet every now and then, but we're constantly telling it to set the bullet to shoot. So as soon as it's been shot, we're setting it again. So there's a discrepancy there as well, like the bullet may be getting shot in the middle, which is convenient at that time that it was getting shot while we're actually facing the robot. Alright, so now that we've done that, I reckon we should upgrade our competition. Oh. Moving around. Trying to take on fire. Now we can look at this little description down here. Sits still, spins guns around, moves when hit. Ooh. Uh-oh. Missing lots of shots. Lots and lots of shots. If we actually let this run through. Oh no! We lose. Alright, so what we've got happening here is that we've got a robot that's moving around and we're losing. So obviously his strategy is move out of the way when you get shot so the next bullet's going to come through. However, even though we're shooting bullets all the time, he only shoots them when he's got a lock on us. So what we're going to do is we're just going to quickly add in some movement. We're going to do this by so this one happens to be in degrees, and we're going to set the head. I'll probably leave it there, so it doesn't take too much time more, but can anyone figure out what's going on in this particular example? Yeah, so there's a couple of problems here. The first problem is that because we've started moving the robot now as well, when you think about moving the body of the robot, if the gun wasn't moving and you move the body of the robot, the gun would move. So now that the robot's turning, while he's turning, the gun's turning, and we're telling it to set it somewhere else, and there's a delay between when it scans the robot. So hopefully you can see that while it's really simple in terms of implementation, there's sort of like lots and lots of different ways that you can try and solve these problems. If you look through some of the other sample bots, there's wall huggers, people that just go into the corner and snipe everybody. Lots of other interesting bots. Tracker locks onto a robot, moves close and then fires. My particular favourite, ram fire, drives at robots and rams into them. You get bonus points for that. And then sort of plows into them and fires and hits them. So just to show you, to finish off, this is called Portia. This is one of the leading robots, I think, at the moment. And we're just going to pit him against everything. I'll show him to you. At all?
Yeah, at all.
Sure, that'll go, we'll see. So, Portia is this guy here. I thought I might have time to show you something else cool, but I'll show you in a second. It's sort of, I guess, the difficult thing with this is you can sort of see how robots play, but it's hard to see what they're thinking. So Robocode is this cool graphical debugging thing that you can put on top. I'll play out around with Portia, and then I'll play out around with this graphical debugging on. And it's actually really cool to see how he sees the world and how he's reacting to it. But yeah, I'm pretty sure he should win. Maybe I'll eat my words, we'll see. So yeah, keep an eye on Portia, he'll probably be the most interesting. So yeah, every time you hit someone, you get some health back.
This guy's in the Matrix.
Who said the thing about the Matrix? Because that was very much correct. He actually does dodge bullets, which we'll see now. So you can turn on, I think I clicked Portia, yeah, we'll turn on paint for this next round. And that'll, like whatever this code author has decided to paint out, so the output we'll see. It's pretty crazy. When we get down to one robot though, it should be fairly interesting. So here we go. So it gives indications of targeting strategies, the blue lines that he's placing. So see that blue line that's coming out? You can't actually tell when bullets have been shot or in what direction or anything they've been shot by, but you can tell that a robot's energy level is decreased. So what this bot does is it checks for hitting walls and kind of cuts those things out and assumes, see how there's that white dot on the tip of that red sort of area? He's guessing where that shot might be and what the most dangerous areas are and avoiding them, and that's a particular technique called wave surfing, which is pretty cool, I thought. Anyway, let's let him win.
Now, these guys can join this comp because it's actually not run yet, hasn't it? It's been postponed.
Yeah, so this comp has been postponed to be running on Tuesday of next week.
There you go.
Yeah.
So I think everyone, can we just give them a thank you. My thought is if anyone really wanted to enter the comp and did something awesome, then that certainly would be the equivalent of a design task, don't you think? Yeah. So you could do that instead of a design task if it was truly awesome. Yeah. If you want to spend this weekend doing it, because there's not much time. What do you think, random tutor at the back? Yeah. What's that? Make it. We should make it a thing. We had something like this a couple of years ago as a thing, but it was very complicated. Rome is very simple. Yeah. But this is awesome. Thank you.
Yeah, a word of warning though, if this does become a design exercise, be careful because it's so addictive and you will spend hours and hours and hours optimizing like the smallest thing.
But how's it been for your Java? How's it helped your Java?
Yeah, well, I mean, I hadn't done any Java prior to this semester, and I jumped into this about 2 weeks ago, and yeah, it's been pretty awesome.
Yeah, I think this is the best way of learning because you've got this real incentive to get something working, so you just drive yourself to work out what's going on. Thank you very much, Mario. That's awesome. Thank you. Thank you.
If we're going to replace our design task, do we have to do it with our design partner?
Who's your design partner? Boy, Stephen, where are you, Stephen? Right up. Stephen, I reckon Stephen should write you a poem in retaliation for that. I don't know. You got to do pair pro. I don't know. It's a hard question. What should the answer be? The answer should be yes. But I imagine this will take vast amounts of your time. What about we say it's not pair programming, but you should do it with them, so you can both just monkey around sharing code between each other and things, but you don't have to sit next to each other.
What if we do it with a friend?
Oh, what if you do it with a friend? Oh yeah, okay. You do it with a friend and we'll work out something. Okay. If your awesomeness blows us away, we'll do something amazing and awesome ourselves.
I'll put up all the resources on the wiki and on the slide for robocode.
Well, thank you very much. Thank you. Thank you. And whoever's doing the lecture notes, could you link to that? Link to /robocode so everyone can see all the stuff. Thank you very much. Yeah, just leave it there. That's fine. That's fine. Thank you. And we'll grab it all at the end if you want. Yeah. Or you can take your laptop if you want it. Okay. So that was really awesome. I love practical applications of stuff like that. When we finished the last lecture, we were just about to guess the meaning of the word final. Did anyone have a guess? Or look it up or already know it? Yes? The person up there stretching and putting up their hand accidentally. Richard, what do you think it might mean? It doesn't mean it can't be changed. It sort of does. It means it cannot be overridden. If it's a class, if you say a class is final, it cannot be extended. If you say a method is final, it can't be overridden. If you say an attribute is final, it can't be overridden. So it sort of protects it. It's rare that you do that. Again, that's almost a design smell because the whole idea, well, the original idea behind inheritance is you want to let the users of your class have the responsibility for working out what they're going to do with it and neat things they can do with it, things you can't even envisage now. Once you start saying things are final, it's sort of like you saying you can use my code, but you're never allowed to do that, and you're never allowed to do this. And it's sort of like you're being all parental and authoritarian, and how's it going to hurt you if they do that? You know, it's not the end of the world, so it might hurt them because they might end up with a tightly coupled mess. But yeah, so normally final is, if you're going to allow people to override, then you might as well allow them to override rather than just trying to give them selective overriding. Well, yeah, I don't know, I can think of, even as I speak, I can think of counterexamples where it's useful, but just be aware of it. Whenever possible, as I think on the forums, whenever possible, I try and I pause a second before answering and try and let a student answer, because I figure you guys give better answers than me and you're more in tune with each other than me, and it helps everyone's understanding if a student explains it. So I could just jump in and answer every question, but I think, no, I'll just wait and see who answers and see what happens. So I have faith in you, and you guys rise to do amazing things. It's similar. You make a class, you're giving it to the world, you're going to allow the world to extend it and do other things with it. Well, then let them do lots of things with it and see what they can do. Have a bit of faith in them, sort of thing. Yep. Okay. So that's what final means. Now, we started talking about all of this because someone asked what abstract meant, or I started talking about what abstract meant. Which was it? When did abstract pop up? Oh, here we are at the top. So we haven't really explained abstract. Oh, sorry. I'm looking at the screen, but you're not. We're now in this world where you can make a class, make it public, someone else can grab your class and extend it to make their own class and reuse all your code. And someone else can grab his class and extend that and reuse his code and your code. It's this world where we're sharing code and things are being reused, and it's wonderful and beautiful, and it's birds in the trees. Now, one thing that I can now do in this world is I can actually write a class where I say what the functions are going to be, but I don't actually write the bodies for all the functions. Now, if you think about it, that's a crazy class. You can't use it because every function needs to have a body. But I could have a class where I give the body for 3 functions and I leave two functions without a body. I just say their type signature. We call it, because it can never be used, no one can ever make one of these things because it's got holes in it. So you can never make a concrete one of these, concrete object. We call it an abstract class. Why might you write an abstract class, which is a class where you give implementations of some of the methods but not all of them? What's the advantage of leaving some methods unimplemented? How would people use it? Yeah? It's like having a class and an interface at the same time, that's right. People extend it, which means they grab all the bodies you put in, and they have an obligation to put the bodies in that you've left out, and once they've done that, they'll have a class they can use to make objects out of. And if they don't fill all the bodies in, then they've just got an abstract class that's got less holes in it. So I could do that with an assignment. I could say, here's an assignment I've written, I want everyone to, here's a Roma game that's half written. I could give you an abstract Roma class that has all the housekeeping functions and does all the I/O and all the networking and all that sort of stuff. And I could just leave one thing empty, maybe the thing that does the strategy. And then you fill that thing in, you say, I'm going to extend Richard's stub, Richard's sample code, extend Richard's sample code, then you give the body for the one missing function, and lo and behold, you've got the whole package. Does that make sense? So it's another way of sharing code. So for example, in the, what was it called? Awesome Robot? Where are you? Where has he gone? Mario, where are you? Wave at me. Oh, yeah. What was the class you're extending?
Advanced Robot.
Advanced Robot. Was that abstract, do you know? Advanced Robot may well have been abstract and may well not have had a run method. So you had to give it a run method before it could do something. Though I seem to remember you ran it without giving it a run method and it worked.
It probably had an empty run method.
It had an empty run method, so it wasn't abstract. It was completely concrete. It had a run method that did nothing. But another thing they could have done was not even give a run method, just give the type signature for run, but not actually give the run method. And then everyone is compelled to put a run method in. Yeah. Does that make sense? So that's an abstract class. It's a class where it's sort of half given and half not. Whew. So now, with abstract classes, with inheritance, and with interfaces, you can see now you can do the same thing in lots of different ways. You can start to half specify things that other people have to fully specify, and you can start saying a function that takes one type, but it can also take other types now as well. So you can say a function that takes an interface type, say, and then anyone that implements that interface can be passed into it. Or you could say a function that takes an abstract class as its type signature going into it. And then anyone that extends that abstract class and fills in all the methods and then creates objects using it, those objects can be passed in. And anything that extends any of those things can also be passed in. And so on, down the tree. Does that make sense? So now we have quite a rich environment and a complex set of things we can do, which is going to start giving us lots of choices, which is going to lead us into the design mess of sterents, unless we think really carefully about what we're trying to do and when we should use one method and when we should use another. And just for the moment, I'd like you to fool around with them and just start to get a feel for the sorts of things you can do. Notice that you implement an interface, you extend, which is interface inheritance, no, there's nothing to say there. Tight coupling. Oh yeah, I wanted to talk about coupling. Coupling is this concept in design. We'll be talking about it tomorrow, actually, on Thursday. When you've got two classes, you want them to be loosely coupled. And what that means is you want to have as few dependencies between them as possible. As you noticed yourself when you did Dracula assignment last year, you'd like to break everything into chunks and have as few interactions between those chunks as possible. That's information hiding. That facilitates modular design, facilitates, it means it's not brittle. You can change one thing a fair bit and not everything else changes everywhere and it's not a big mess. The more loosely coupled, we call that loose coupling if you pull that off, the more loosely coupled things are, the better the design, we normally say, because you have enormous freedom in fooling around with the components and the other components just sit there unchanging and everything still works. And so the inheritance, the reason we're often a bit sus about inheritance is it's a bit of tight coupling there. The child class is tightly coupled to the parent, and it's sort of working on the assumption that the parent isn't going to change very much. And so if you start fooling around with the parent, you can muck up the children. It's so true. There's that awesome poem. Oh, I see. No, I didn't quite mean that. There's this awesome poem called This Be the Verse. Does everyone know that? By Philip Larkin. That's very good about that. Okay. Awesome poem, not a bit of doggerel. Pros and cons of inheritance. There's the advantages. Quick method of code reuse. Woohoo! Subclasses can be used anywhere the parent class was used. Woohoo! You don't have to change the parent class. You can just extend the code. So anything that depended on the old class still works. Woohoo! That's the OpenClose principle. That's the close part. We really like that. Disadvantages. It can violate the principle of abstraction. It can be neat, but it also means the child needs to know how the parent works. And if the parent changes any of its internals, even if it still compiles, Even if it still complies with the public contracts, it can break the child, i.e. the child can rely on more than just a public contract. E.g. the child can access internal methods and attributes of the parents if these attributes and methods have protected access rather than private. E.g. if the child replaces any of the parent's public methods which are called by methods in the parent. And then I just wanted to talk about hand gliding again, because I'm pretty sure I've said this to you before. I think I've told you the story of how when I was learning how to hang glide years and years ago, and I was nervously asking, am I going to die? The instructor said, really, you're probably just going to get serious injury at worst. And that's only going to happen when you land, and that'll probably only happen if you crash into a tree. And we're going to be landing in a paddock, and it's only got one tree in it, so you're probably okay. And I say, how often do people crash into the tree? And there's this sort of embarrassed pause, and he says, well, actually quite often. Even though it's a very big paddock, people, he doesn't know why, always seem to crash into the tree. And he said he has this theory that you steer the hang glider by angling your body, and it sort of goes where you're pointing your body. And you sort of point your body where you're looking, and if you're worried about crashing into the tree, you sort of look at the tree. So there's this sort of bad feedback system going on there. And for me, I think inheritance is a bit like that. Because these abstract, super, sub-final, all the overriding, subclassing, all this stuff that comes with OO is probably the main thing about OO programming that's different to your normal programming. And when you start learning OO programming, it's, I think, the thing that we concentrate the most on because it looks the most different. So we start to think a lot about inheritance. We start to think a lot about inheritance mechanisms, and it's just in your mind all the time because it's a new thing. And then I think as a result of that, people make it quite a big thing in their mind, and then they start using it everywhere. And they start thinking everything's got to be inherited from something else. And it's like the hang glider problem. I think inheritance is cool. It's this nice little trick. Don't use it too often. It's actually caused a lot of problems because of the tight coupling. So try and use delegation whenever you can. And if you just think about inheritance all the time and stress about it, then you'll probably start using it a lot and everything will be a mess. So just don't do that. Just relax. It's a little thing. Use it sometimes. I haven't needed to use it for any of the assignments so far. The tutors and I were discussing the last assignment, the chess assignment. There's some scope for using inheritance in the chess design project. But my solution didn't actually use inheritance. I don't know if inheritance is the right thing to use there. There's a small scope for it. You can probably see a bit of code reuse between different pieces, basically. But yeah, just think about that a little bit. Yeah, I think so far we haven't actually really needed to use it so far. Okay. All right. Now, there's two... I won't talk about namespace pollution. We can talk about that later on. There's two useful classes that you should know about. But they're both in the java.util package. One's java.util.random, which you can use to generate random number generators, which can themselves be used to generate random numbers. And java.util.listArray. List arrays are really cool things. They're lists, but they're implemented with an array underneath them. And the nice thing is, if you want to have a list, instead of having to set it up, you just say, I'll use a list array. And then you can just throw things in the list and take things out of the list. And if it's not big enough, if the array underneath isn't big enough, you know what Java does? It makes it bigger for you. So you never have to worry about things overflowing or so you say, I'll have a list array, and you just throw things in and pull them off. So if you want a list of something, a list array is quite an awesome thing to have. So do look both those up and just check them out, because they might give you enormous amounts of pleasure. Interfaces, I don't think I'll talk about interfaces. Yeah, actually there is something I want to say about interfaces. It turns out that interfaces can inherit as well. It's not just classes. So if you've got an interface, you can say, I've got an interface for a list. I've made a list interface. And anything that implements that behaves like a list, and we can use it in things that expect a list. You could come up with something called a sorted list interface. Now, a sorted list interface has everything that the list interface has in it, but it's also got some extra functions that lets you specify, I don't know, a sorting function or something. Instead of writing both those things out and having a lot of code duplicate, a lot of type methods duplicated between them, you can just say sorted list interface, interface sorted list, extends list. And now you get all the methods in the other interface automatically added into your interface, and anything that implements extended list interface is now automatically implementing the list interface. So if you've got something that's an extended list, it's now also, you've told Java, a list. So that's very convenient. So you can have a hierarchy of interfaces as well, just to throw something else into the mix. Now, There's two things I really want to do. And how long have we got? 5 minutes. I think we've got time. One of them is, there's a bit of a debate in the Java world about the proper use of interfaces. Because although if you've tried to do it, I hope you have all tried and fooled around with interfaces, if you've tried to do it, you'll notice you can't put attributes in an interface. You can only put methods in an interface. But the exception for that is you can have constants in an interface. You can store constants in the interface and methods, but you can't have variables in the interface. And there's a debate in the Java world about whether you should do that. Whether interfaces should just contain methods, or whether it's okay for interfaces to contain methods and constants. And you can imagine the argument in favour of constants is something like, people are using my interface to do with university students, and it's really important to know that university students have an ID code that's 7 digits long. So that constant 7 should probably be stored in the interface, so anyone fooling around with uni student accessing function things knows how long the student numbers are. So that's seems a reasonable place to put it. But then other people would argue, well, no, constants tend to be an implementation detail, and interfaces should be fully abstract, just describing what you can do with the things. And any implementation details shouldn't be in the interface, they should be actually in the body. And that gives you freedom later on to change all sorts of things without breaking people that are using that interface and relying on it. Does that make sense? So it's a big debate going both ways. Here's an interesting link that I'm going to give you. I was going to go through it in class, but because I'm so keen to do the very last thing, I won't. It's a debate between two people. Someone saying, oh, my mate reckons you shouldn't do it, but I reckon it's okay. What do you think? And then all these people from around the world saying, oh, you should do it, man. It's really good. And no way, you shouldn't do it, man. It really sucks. And there's a lot of people arguing, and it's a design debate. And I'd like you to just read through it and see who you agree with. And look, some of the people in there are idiots and just saying what they think. And some people are trying to reason it out. And just read through and you yourself decide at the end, do you think you shouldn't do it, or do you think you should do it? And make sure you can understand the difference between the arguments both sides are giving, because some of it's a bit subtle. So that's a sort of a homework. I won't kill you if you don't do it, but I think it would really help you if you went through reading that argument. And the interesting thing is, someone refers to a point made by Joshua Block, where he's against it, and everyone's saying he's an academic idiot, except the people that think he's wonderful and saying he's incredible and wonderful and he's absolutely right. Neither position is, of course, the truth. The truth is you have to read through and work it out. But the interesting thing is, here's the famous programmer that we'll be talking about on Thursday, because as you know, I'm reading from this book that I really like about interviews with famous, awesome programmers. And he's our guest visitor on Thursday, which leads to the last thing I wanted to do, which is this really nice thing I spotted recently on Reddit, which is conversations with average programmers, where based on that book, someone's interviewed an average programmer. And I thought we'd just rather read that. Let's read that. Only takes a second, once it's loaded. Uh-oh, this is a Reddit effect. What's happened? We're dead. Click. Click. That's what I want. Oh, what a pity. Let's try it one more time. He's gone down. I bet 1 million people from around the world are reading it. Oh, you've got it there? Can I read it off yours? It's just my computer's gone down. Thank you. Oh, thank you. Interviews with average programmers. Blah, 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 blah. They refer to that book that I really like, saying, oh, everyone likes that book these days. Blah, 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 blah. But I thought I'd interview myself. Interviewer, how did you first get into programming? Me. Well, I was meeting my career counsellor one day to figure out what I should do with my EE degree. Interviewer. Oh, so you have a degree in electrical engineering? No, English education. Anyway, he had this problem with his computer. He couldn't open an email attachment or something, and anyway, I got it to open for him, and he said I was pretty good at that and I should go into computers, so here I am. Well, yes. Many programmers don't take the conventional route and get a CS degree, so that's quite legitimate. No, so tell me, what languages do you know and use regularly? Me. Oh, lots. Specifically, can you name a few? Me. Sure. Well, I'm most comfortable with Java 2. But I also know Java 1.4, Java 5, and even some Java 6. I know Java Swing and, of course, Java Collections pretty well. Some Java Servlets too. Interviewer. Okay, those are all the same language. Do you know anything else besides Java? Lang. Oh, Erlang, really? What have you done with Erlang? No, sorry, I was starting to say languages besides Java. I'll have to think about it some more. Oh, okay, let's move on then. What's the most complicated piece of code you've implemented? Oh, that's easy. One time I had to sort a list of numbers and I did a sort in one line. Really? You've implemented a sorting algorithm in one line of code? That's very impressive. Donald Knuth would be so proud. Me. Who? Interviewer. The father of modern computer science and the author of the seminal Art of Computer Programming series? Yeah, well, if you like sorting, you should check out Java Collections, one of the languages I know. You can do a sort with just collections.sort, and it sorts to any collection you give it. Boom, one line. If you give me his email, I can tell him where to find it. Oh, that wasn't, you asked that question. Okay, let's keep it going. What are your thoughts on pair programming? Do you practice it often? Absolutely not. I mean, don't get me wrong, I don't judge others for doing it. I mean, I have been tempted, sure, but I'm a happily married man and... Okay, let me stop you there. I'm pretty sure we're not talking about the same thing. Let's just skip a few of these questions. Okay, here's a safe one. What are some of your favourite tech books? Oh, probably Teach Yourself Java in 21 Days stands out. It got me up to speed in my first language, Java 2. And very quickly too, I might add. I actually read most of it in 20 days, so I figure I'm probably ahead of the curve somewhat. I've always scored pretty high on reading comprehension. Also have one of those books with a picture of an animal on the cover about XML. Oh, that's what I was trying to remember from your what language do you know question. I know XML too. Not sure XML is really a language. Oh, okay, sure, no problem. Just keep me down for Java servlets then. In fact, maybe count it twice, because I know it pretty well. Okay, anyway, it's very funny. Thank you. Yes. Okay, so I'll see you all on Thursday, where we'll hear Joshua Block speak through the mouth of Richard.